Today we're diagnosing P0340 on a 2015 to 2025 Ford F150 with the 2.7 EcoBoost. In plain language, this code means the PCM may not be seeing a usable camshaft position signal from bank 1, sensor 1, or that signal may be dropping out. The truck may have a starting complaint, may run with a cam timing or sync issue, or may simply store the fault intermittently. Broadly, possible fault areas can include the CMP sensor circuit, connector or harness condition, electrical interference, oil or VCT-related cam positioning concerns, base engine timing concerns, the CMP sensor itself, and less commonly the PCM. We're going to keep this diagnosis electrical and logical. Confirm the code, inspect the harness, try to make the fault return, then prove power, circuit integrity, shorts, sensor operation, and final verification. Start with the basic system checks, then check for stored DTCs. For this episode, we're focused on P0340, but if other cam sensor or synchronization codes are present, treat them as context and check what they mean before jumping ahead. If P0340 is present, and the vehicle also has a no crank or no start symptom, this diagnostic path moves directly to the CMP sensor voltage check. For the normal path, continue with the harness inspection. If there are symptoms but no DTCs, the path still starts with the harness inspection. If there are no relevant symptoms and no codes, this P0340 path is not the right place to keep guessing. With the ignition off, inspect the CMP harness closely. Look at routing, any harness alterations, shielding concerns, and possible electrical interference from nearby systems. Also check the CMP connector for damage or corrosion. This matters because a cam signal can be affected intermittently by routing problems, shielding problems, corrosion, or outside electrical noise. If you find a problem here, repair it as needed, clear the PCM codes, and repeat the self-test. If the harness and connector look good, move on and try to reproduce the fault. Next, clear the code and attempt to retrieve it again. Turn the ignition on, start the engine, and raise engine speed to greater than 500 RPM for 10 seconds. Do that 3 times. If the code returns, continue into the noise and circuit checks. If symptoms remain but the code does not return, step back into the symptom-based path instead of forcing this test. If the concern is gone and the code does not return, verify the repair path separately. Also keep in mind that ignition noise, alternator noise, radio frequency interference, and crank sensor concerns can affect this type of cam signal diagnosis. On VCT-equipped engines, oil level, oil filter condition, oil contamination, or VCT system concerns may cause cam positioning errors. So don't ignore those if the electrical tests do not line up with the complaint. If P0340 returns, check the generator for excessive electrical noise. Start the engine and listen for audible electrical noise from the generator. Then turn the ignition off, disconnect the generator regulator B+ connector, restart the engine, and listen again. If the generator noise stays steady with the B+ connector disconnected, keep going with the CMP circuit diagnosis. If the noise changes, diagnose the noisy charging system condition before continuing, because electrical noise can corrupt the cam sensor signal and send you down the wrong path. Now diagnose the suspect CMP sensor indicated by the DTC. With the ignition off, reconnect the generator regulator B+ connector if it was disconnected. Disconnect the CMP sensor connector, turn the ignition on, and measure the voltage at the specified 2.7 EcoBoost CMP connector pins for the suspect sensor. The voltage check is looking for either greater than 10.5 V on the VBPWR circuit, or between 4.5 and 5.5 V on the VREF circuit. If the correct voltage is present, move on to the open circuit checks. If the voltage is not in range, leave the CMP sensor alone for now and diagnose the power or reference supply path before going further. Next, check the CMP circuits for an open. Keep diagnosing the suspect CMP sensor indicated by the DTC Disconnect the PCM connector and measure resistance through the specified CMP signal and return circuits for the 2.7 EcoBoost. The resistance needs to be less than 5 ohms. If it is, continue to the short checks. If it is not, repair the open circuit, clear the PCM codes, and repeat the self-test. After the open circuit check passes, check the CMP position circuit for a short. Measure resistance across the specified CMP circuit pairings for the suspect sensor. The resistance should be greater than 10k ohms. If the resistance is not greater than 10k ohms, repair the short circuit, clear the PCM codes, and repeat the self-test. If the resistance passes, continue to the short to voltage check. For this short check, some lead pairing detail is unclear, so do not assume a missing meter connection. Pause, confirm the correct circuit pairing, and avoid guessing before you put the meter on the circuit. Now check the CMP circuit for a short to voltage. Turn the ignition on and measure for voltage at the specified CMP signal circuit locations for the suspect sensor. The question here is simple. Is any voltage present where it should not be? If voltage is present, repair the short circuit, clear the PCM codes, and repeat the self-test. If no voltage is present, move on to checking CMP sensor operation. The meter return lead detail for this 2.7 EcoBoost voltage table is unclear, so again, do not guess. Pause and confirm the correct test hookup before continuing. With the circuit tests passed, turn the ignition off, reconnect the CMP sensor connector, reconnect the PCM connector, and start the engine. Access the PCM data and monitor the sync PID. If the engine starts and sync reads YES, continue to the final DTC check. If the engine does not start or sync does not read YES, this diagnostic path calls for installing a new camshaft position sensor, then clearing the PCM codes and repeating the self-test. Keep verification separate from the electrical testing. After the checks and any repair action, check for DTCs again. If any DTCs are still present at this point, this path calls for new camshaft position sensor, then clearing the PCM codes and repeating the self-test. If no DTCs are present, the system is operating correctly at this time. The concern may have been caused by a loose or corroded connector. Clear the PCM codes and repeat the self-test to make sure P0340 stays gone. The takeaway on P0340 is not to jump straight to a sensor. Confirm the fault, inspect the harness, reproduce the code, rule out electrical noise, prove voltage and circuit integrity, then use the sync PID and final DTC check to finish the call. For more diagnostic training, visit stepdiagnostics.com.